At this time, I would like to introduce our next speaker, Charles Hammock, Jr., P.E. Charles Hammock, Jr., P.E. started design HVAC systems after receiving his Bachelor of Mechanical Engineering degree from Auburn University in 1983. He is a registered professional engineer in several states and one of the three founders of Andrews, Hammock, and Powell, Inc., a consulting engineering firm established in 1988 and located in Macon, Georgia. During the past 36 years, Mr. Hammock has been extensively involved in the engineering of HVAC systems for government, industrial, commercial, and institutional clients at facilities throughout the United States and internationally. Systems designed and installed for these projects range from small DX split system heat pumps to the installation of large central chilled and hot water systems and steam plants. He holds professional memberships including ASHRAE, USGBC, ASME, International Ground Source Heat Pump Association, and others. If you please will join me in welcoming Mr. Hammock.
Mic check. Wow, that ought to be loud enough. Green is forward. Not yet. I just went to Auburn. I don't know how to run those things. Hope, there we go. Yeah. All right, I'm just Chuck, not all that other stuff. So, does anybody know what happy hour is? Yeah, I bet you do. All right, so this is 3 for 1 right now. We're going to do a little trivia. And then I'm going to say a little bit. We appreciate all the excellent speakers that came before you hit the bottom right now. So, just hang in there, but I'm going to try to keep you awake. I appreciate all the vendors that came. I appreciate the talks about VFDs and advanced tab. I'm going to touch on a couple of thoughts on their 2 talks because I really enjoyed them. And then we're going to kind of talk about what Mark Andrews put down for my title, but I changed it around a little bit. I figured, the biggest thing is, you got the mechanical contractor doing his thing, and you got the consultant engineer doing his thing, and he's a PE, so he must know everything in the universe, right? Except that some of these guys, and I'm one of them, have never worked for a living and cut their hands on sheet metal. Now, I have cut my hands on sheet metal and doing pipe. My daddy ran a lumber yard, so I had to start work early, working in ditches before OSHA came around that were about this tall. And some of you frost your hair like I do. Has anybody ever put together a pipe with lead and oakum? Huh? Mark Andrews? Breathe those lead fumes? So anyway, one of the big problems is my industry. We got nerds, super nerds would be like scientists. And then engineers would be kind of somewhere in between science and actually working for a living, right? And then we'd have contractors. So, my industry is a part of the problem. But how do we get the tab guy and the commissioning guy and the mechanical engineer and the HVAC contractor and the control contractor, how do we all get them to sit around the campfire and hold hands, sing Kumbaya? Huh? Happy hour, that's right. So, in fact, I have a slide on that. I have a slide on lunch and learns, and then later on in the afternoon, I have another event that you might consider holding at a local brewery. That's worked out. The smartest salesman that have ever called on our office, they took us to the brewery in Macon, Maconga, where I live, Macon, Georgia. Jeremy Knowles, a friend of mine was a chemical engineer practicing HVAC, but with a good 6-figure income, decided to quit that stuff and brew beer. for a living because he wanted to. So he did a good job. He brought back our first brewery since Prohibition and brewed some good beer, but it was a lot of work. He didn't make a whole lot of money, and he ended up selling it to some other guys in town. But we've enjoyed going over there at 5 o'clock, for a couple of his deals. So anyway, I just want to say thanks to Dave Odell and Travis Short and the vendors that have spoken before. And then I'm going to hit you with a little, so that's item one. Item two is just a little quick trivia and a couple of thoughts on their talks, and then we'll get to my talk. So, all right, so let's first do, what do we want to do first? Let's do trivia. So who has had to deal with turbulent flow before in some way? Okay, and now this is rare that you run into this, but how about laminar flow? Have you had to deal with laminar flow? Laminar flow is kind of weird. The only time we know, there's some laminar flow hoods, that means we don't want the crap to get stirred up and somebody breathe it. You ever done a desiccant wheel or an energy recovery wheel? So those are itty bitty little straws, and the flow through those is generally laminar. And so the stuff you've been learning, you can throw it in the trash can because the pressure drop goes as the first power to the velocity through there. So it doesn't go as the square, it goes as the one. So you double the CFM, double the pressure. You don't go to the fourth power. So, and I'm going to screw you up a little bit more and talk about horsepower, not quite going to the cube sometimes. But anyway, there's laminar and there's turbulent. And then does anybody know what's in between? Here you go, Mr. Hardy, who he and I worked together forever. Well, not forever, for many great years, right, Clint? We left this unnamed firm and started Andrews, Hammock, and Powell in '88. And Clint and a couple of his buddies were like, "Wait, why are y'all leaving?" And I said, "You're fixing to find out." And then a couple of years later, they started Technicon, which is now Clark Nixon. So we learned at a great place because we had to work 3,000 hours a year. So and the turnover was higher than McDonald's. So you got to be a senior engineer in about 20 minutes, So we started our firm. We said there's two things we're not going to do. Nobody's going to own 51% because y'all sit around and vote, and guess who wins? And we know who used to win, don't we, Clint? And then, so that was one of the things we did. And then we said a measure of our success would be low turnover. And so that worked out well. Our first intern is a partner now, and he was dumb enough to come work out of Ed Powell's basement on a pool table, and then we moved into Ingleside Avenue, and Madge Elegance Dress Shop was our office. And we're a little bigger now, but Wesley's been with us since the beginning. So here's a trivia thing. Who do you think came up with the Reynolds number? Reynolds is a really good guess. His first name was Osborne Reynolds. Brilliant physicist, did a lot of great stuff. There's an obscure thing unless you go to, how many of y'all had to go through the misery of engineering school, mechanical? So you remember Navier Stokes? Anyway, Stokes invented the Reynolds number, and then a German physicist, but he didn't really talk as much as me. So, and some people have put $100 if I'll finish on time, then they're going to give me $100. So y'all are in good shape. You're not going to have to miss happy hour. Anyway, crazy thing, Stokes invented it, but then Reynolds made it popular. And so, this German physicist told everybody about Reynolds. So now it's a Reynolds number from now on. And the weird thing about it is, I liked one of the things that Travis said earlier, which he used the word physics. You generally can't violate physics unless you're God, and then you create it, and then we all have to try to figure it out over time. But we found sometimes more on the commissioning side than the tab side is the horsepower or the energy is not going as a cube. So you put a VFD on. I'm not picking on VFDs because I like Dave a lot. He's taught me a lot. I'm going to hit a VFD thing. But you put a VFD on there and there's a certain amount of energy, and then you hack it in half or cut some fan that's stupidly running, just wide open nuts, and put a VFD on there, cut it in half. So half times a half times a half is an eighth. And then the energy's maybe a little more than an eighth. So what really happens is, this is trivia, believe it or not, nerd trivia. These things we treat as constants, like the efficiency of a fan to turn rotational energy into air molecules zinging down the duct, that's not necessarily a constant. It's close, but it's not really constant. The VFD itself, Dave and I were just talking, the losses through the VFD, the wattage in and the wattage out, is pretty close. I mean, maybe 98%, 97% of it makes it out the other end. And if you do data loggers, be careful, because if you're doing a VFD and you're trying to measure the juice downstream of the VFD, you better make sure your data logger can handle something weird like 240 volt power at 30 hertz. That'd be half speed. A lot of them are calibrated for 60 hertz and watt nodes and all those other ones. They do a lot of neat stuff, but they're not necessarily able to deal with something other than 60 hertz, or if you're European, 50 hertz. Look, if you're from Ireland, we've got one guy here all the way from Ireland. Raise your hand. Stephen Greer. He just came to see me. He came all the way from Ireland, Belfast. We got to be friends a long time ago, and people say, your Irish accent sounds a bit Australian. I said, well, I did 23andMe the other day, and I know it's going to be hard to believe, but I was just like, Mr. White Toast or whatever. I was Scottish and Irish and English, a little bit of German, not a lot, a little bit of German, and a little bit of French. But that was it, man. So couldn't I have something interesting in my DNA? But Stephen Greer is a great guy. Came to Georgia, fell in love with a Southern belle, got married, lives in Birmingham now. So he's a neat guy. But anyway, we found sometimes the horsepower goes to the 2.6 power. It's not squared, it's not cubed, maybe 2.8 power. And that's basically because as you get down in the low end of things, these efficiencies start changing. So it's not really that physics doesn't work. It's just that. And if you're old like me, you used to use pipulators and ductulators. And now we got, apps that do it. And the app will actually tell you, the B&G one will tell you it's transitional flow or turbulent flow or whatever. We crunched out a number just a minute ago. Transitional flow was a 2-inch pipe. How much going down it? Anyway, when you read the two PDs, friction per 100 foot off of that sucker, it was varying by the 1.85th power. So laminar, I told you, was linear, and turbulent is square. But in transitional zone, it's somewhere in between the two. So that one went to the 1.85 power. But for 99% of what y'all do, forget all that. I just want to share a little trivia that sometimes things don't line up. And I guess I bring that up because Brandon Cave said to me, he said, can you get it into the engineer's head that, this isn't a laboratory? We got to get up on a ladder and measure that airflow, and they're trying to move in the building and all that other stuff. So, engineers are a little nuts sometimes, thinking plus or minus 10% isn't enough. That's close enough. My gosh, your loads weren't that good, so. Quit beating up on the tab guys. Last couple bits of trivia, I'll tell you, VRFs are very interesting. The federal government allegedly has banned it. On the Air Force says none, don't do it, and Navy, Army says only under certain circumstances. And I don't think VRFs are bad. People will tell you I'm very into geothermal systems, and that's really only because of a Frenchman named Canu, or as we say in Griffin, Georgia, where I'm from, Macon, Carnot. And Carnot said he figured out that the difference between the high side and the low side is what really determines the potential amount of energy you have to do. So all you really need to learn to be a thermodynamic expert is that stuff flows from hot to cold. That's really the only way it can flow. And you got to learn also that you can't really destroy mass. So, you know, when you add up all them CFMs, they should kind of add up, but it's not really mass, it's volume, and things get hot and cold, so it gets a little crazy. But, you know, GPM in a tight range of temperatures like we normally deal with, that's pretty much mass flow, so it should add up. So if you remember mass flow adds up, and if you remember stuff can only flow from hot to cold, then you're in good shape. And only reason I like geo is because we do this crazy thing where we're sitting in this room at 72 degrees, right? And then outside, God forbid, it was 103 the other day, and we got to move heat uphill. Well, you can't do it. So, you know, what do you got to do? You got to run all these compressors to make all this cold refrigerant. You know, you got to run 40-degree refrigerant or something to get 55-degree air, and then you blow the 55-degree air in here, and then you got to dump it now. And when you go to dump it, it's outside and it's hot. So you're having to move heat from the 72, or just say that's 45-degree refrigerant, you know, up to 130 degrees on the condenser unit. So that more than anything, that spread is what determines how much energy you use. And I like the dirt because at my house it's about 69 degrees, about what I want my house to be year-round. So I can dump the heat into it cheaper than I can dump it into the air, and then I can suck it out of there cheaper than I can suck it out of the air, because how do we heat with a heat pump normally? We run the coil, you know, sub-freezing, and then the air says, well, screw that, I'm going to freeze. So then it freezes out, right? And now we go into a defrost cycle, which means we put it back in the air conditioning mode. But everybody's going to bitch about that because it's going to blow cold air, so then we cut the strip heat on to try to offset it. So anyway, I just like sucking the heat in and out of the ground. But it's expensive. Drillers don't work cheap. And I like to store it, too, because you can't store it. I say when you dump the heat on the site from a cooling tower or a condensing unit, God takes it away so far. And then if you put all this waste cooling in the air, God takes that away, too. So you've lost it. Stick it in the ground, use it next year. But that's a topic for another time. So anyway, I just want to tell you, VFR, variable refrigerant flow, VRF, sorry, dyslexia kicking in again. VRF's a neat thing. It's just weird to me that I loved them because I started out doing a lot of water source heat pumps. And in a school in the winter, we got to heat the lobby, right? And then the computer room, we got to cool it. So I got to run 2 different compressors to do that. But VRF seemed to be the answer, because I could just, you know, move the heat over here on the hot side and then over here on the cold side and run 1 million refrigerant lines in a magic box, and it all works. But it's weird to me, the heat recovery VFR EERs are lower than the straight cooling ones. So that doesn't make sense. And I'll bring all this up because I heard somebody over here saying, I got an engineer that wants me to get the performance capacity at peak load on all these VFRs. So, I mean, what are you going to do? You're going to run around the building and get, 15 of these little cassettes you can't even measure airflow on there, and then try to measure the wattage. It's nuts. There's no way y'all can do that. And that's an engineer with his, how do I say it politely, his head up his butt, and asking y'all to do things you shouldn't have to do. Last piece of trivia. Why do we call it a ton? Anybody going to jump at that? Exactly. Before Willis Carrier and all them other guys talked us into using all these compressors, you just bought ice. So if you buy a ton of ice, 2,000 pounds, English units, right? Even the English don't use it, but we still do. And don't get me going on that, because there's something called EER, which is BTUs per hour per watt. That's English over metric. And really don't get me started on SEER, because SEER is a bit of a game, because that Carnot thing, if you'll just get it cool outside, you can get a really good SEER rating, and the EER rating may be 6 points lower, 8 points lower. You got one salesman talking SEER and another one talking EER. Some equipment isn't rated EER, so those are those are two different things. But where the hell was I going with that? Melting ice. Thank you. All right. 2,000 pounds. You call up the ice man. I need 2,000 pounds of ice. He brings it over there to the house. And every time you turn that solid into a liquid, you have does anybody know what that's called? Anybody remember? Latent heat of fusion. It's latent just means hidden. It's like, what your wife's really thinking. Just tell me. You should know. I'm kidding. Is my wife here? She did a tour. I didn't figure she'd punish herself by coming in here. So 2,000 pounds of ice. Takes 144 BTUs to turn that from a solid to a liquid. And you want that to last you a day. So you divide that by 24 hours. And the magic is 12,000 BTUs each hour for that day. So that's where a ton comes from. That's all it is. It's 12,000 BTUs an hour. You throw that into a ton of ice for a day. You'll have used a ton with your refrigeration system each hour. Or if you deal with ton hours, it's 24 ton hours. 1 ton times 24 hours. All right. You're free of that insanity now. So I'm going to tell you a little bit about me, but hopefully not a lot. And then I want y'all to tell me a little bit about you. And then we're going to talk about control systems and sequence of control challenges and some commissioning challenges and the tab challenges. And I put expanded tab up there because a very famous tab person told me, half the time we end up having to do commissioning. And I'm like, yeah, that's true. But some of our clients won't let us do commissioning. So we just hide it in the tab spec because they're used to paying for tab. So that's all that expanded tab is. And really what I want to talk about is the last 2 bullet points are how do you make things go better with you and the engineers? And how do you do your jobs more successfully? And how do you level the playing field? So if you do an apple, your competitor doesn't do an orange. Or maybe, I don't know, that's the big price difference. I don't know. Somebody does a watermelon and somebody does a grape. That's probably don't cost the same price. You're going to have to hang in there a little bit on the bullet point 3, 4, and 5 because those are all challenges. This is a fancy word for, I don't know, crap that doesn't go right, And then we're going to figure out in the next one how to do the rest of it. All right, so I'm a mechanical engineer. Auburn started co-oping in 1980, and I guess I did okay. They offered me a job in '83 when I got out, and all I've really ever done my whole life is HVAC design. And but I've done a few weirder things. I one time was doing mostly construction admin work. I think one of the biggest problems with engineers is some of us don't have any common sense or had to work with our hands or have had to weld or bend tin. And luckily, because of my daddy and the Andrews part, Al's dad had a fire protection and plumbing company, so he was very practical of that. And Ed Powell is actually an Aggie from the University of Georgia, and he will proudly point out that they laid out the campus of the North Avenue Trade School. Anybody know what that is? Before GovTech came along, the engineers at UGA laid it out. So Ed had a lot of common sense, and that helped a lot, which I think helped us do a little bit better. And then the famous Mark Andrews, director of the MEBB, raise your hand, Marky. Mark came on in 2003, and we started doing some tab and commissioning, but generally only, we do market commissioning services. Tab is normally just like, we do a lot of chicken plants, and you guys would rather, be in a building that's carpeted and air conditioning, and we couldn't get any tab guys to go in a chicken plant. And I was like, smells like money to me, man. Mark was a little younger then back then, so we go to those chicken plants, and man, they stink, and your wife won't let you in the house because you wash clothes, but they also use 2 million gallons of water a day and inside the plant, and it rains, and then USDA doesn't like the rain falling from the ceiling. So we've gotten to do tens of millions of dollars worth of industrial drying systems, we'll call them, where we blow 70, 80 degree air out at a -10 dew point, keep that stuff from dripping down. So that's kind of fun. That kind of came from when the Yankees changed the code and said, 2.5 CFM a person is not enough. You're going to die. You're going to get sick buildings. And so it went to 5, 7.5, 15. And you're like, holy shit, excuse my language. It's raining inside the buildings now, all this DX equipment can't handle all that moisture. So we had to figure out ways to strip the moisture out of the air. And that helped in the industrial work. And then probably in the last 10 or 15 years, I've been doing a lot of geothermal heat pumps and some really weird ones. I'll show you one of them. The one in the bottom corner there is over in Albany, Georgia. Georgia, even though we're considered backwoods, we've got the only borehole thermal energy storage system in America, and one of the few in Albany at the Marine Base, and then one of the few aquifer thermal energy storage systems at Fort Benning. One of the few in the country. All right. Who does TAB on a regular basis? Who's involved with TAB? All right, down. Commissioning. All right, so what are we, 5-1 or something? Both. We're the same guys. All right. So, all right. How about engineering design services, doing design? All right, about 5, 6, 7 of us. How about actually installation, HVAC install? I think generally you don't see a lot of that, but does anybody do the actual installation of controls or chillers or anything? All right. Those are usually your clients, right, that hire you to do the tab or the commissioning. All right, how about this? I know some of y'all are AABC also. How many AABC people? All right. And I got some bad words coming up in a minute, but BCXA, whatever, but anybody do BCA? All right. ASHRAE, CPMP, but then now they want to get some ANSI thing, so they're changing that to a BCXP, I think. Anybody do that? Have that certification? One. TABB. Wow. Now that's are y'all in Atlanta or where are y'all at? Charles, okay. I looked online and I could find like 4 tab firms. Is it 100% union shop? Okay. And then NBC. Now I'll have to tell you, I'm conservative, so I kind of go for Fox. But anybody ever heard of NBC? You got any NBC people in here? Yeah, that's a bad word. Some people told me. So we'll talk about how to deal with NBC, ABC, and CBS. I'm kidding. We may talk about NBC a little bit. All right, how about plan and spec work? If plan and spec work is the majority of your work, raise your hand. All right, negotiated work, where you don't have to put a bid. That's the majority of your work, all right? Design build. Okay. So anyway, those are 3 different market sectors, and each one has a different thing you have to do. And typical client, who would say your majority client or the majority type projects you work on is K through 12? Anybody? Okay. Universities. All right. Private sector. Nothing to do with government at all. All right. DOD, or let's just say any federal government. All right. State government. All right. What am I leaving out? All right. So that's kind of, anything else? Municipal, but that'd be government, right? I mean, there are a few private utilities, but. All right, what do you like to do the most? Tab, commissioning, or you don't care? Tab. All right, commissioning. All right, both, you don't care, either one. All right. All right, what does keep the faith mean besides, believing in Jesus Christ? Keep the faith just means, look, at the end of the day, you guys are kind of the last line of defense. The engineer's done his thing, and the contractor's done his thing, and everybody's leaving the job, and you can't get the control guy on there. If y'all don't get it figured out, and I don't want you to go bankrupt, but if y'all don't get it figured out on the tab side or the commission side, the owner's going to end up with a crappy building. So, you're doing a good job, or do a good job. I hope you're doing a good job, but try to do a good job. The built environments where, God forbid, we spend a huge amount of our time, and And what y'all do is important, and I would like to encourage you to do a good job. And you are important. All right, controls, the bane of almost everybody's existence. I think we have 2 clients that love their control company. Yeah, it's hard to believe, isn't it? All right, so ASHRAE gives away BACnet. So a lot of people say that that's kind of going to be the standard. LawnWorks is certainly out there. Everybody dealt with Lawn before? LawnWorks, Lawn Talk. You got to write a check to the Echelon company or whatever to get the chip in there so they'll talk. So some people say that's going to go away. We do a lot of industrial stuff, so we deal with Modbus. Anybody ever have to deal with Modbus? You know, Modbus has been around forever. You can run it on an RS-485 network. You can run it thousands of feet. It does a little better than Ethernet at long distances. But I just put those 2 little icons up at the bottom, you know, to say that it sure would be nice if this was like a computer. You know, you buy a hard drive and a screen and RAM, and somehow they all say kumbaya, you know. But Johnson and Automated Logic, and I mean, just click them on down, you know. They don't necessarily like to play together. Now, I mean, ASHRAE's trying to pull it all together into BACnet, but it's hard to do that. And things are getting more and more complicated. Sequences of controls are overly complex, probably because they're written by engineers that don't actually have to go out there and make it work, right? And then they got to be customized for each job. Sometimes they're not thought out. Sometimes you can't even achieve it. This quote is accredited to Albert Einstein, but there's some discussion whether he really said it or not. Everything should be as simple as possible, but not simpler. I think that's good. That's what you should always shoot for. Tighter energy codes. You know, engineers are expected to use equipment with higher and higher efficiencies, and yet that creates a set of problems we'll touch on in just a minute. Clients are expecting more and more for less and less. We got I think America has 10 lawyers for every engineer, as opposed to the places that build a lot of stuff where they have 10 engineers for every lawyer. You know, I hate to pick on variable refrigerant flow, but you know the key to being able to build a VRF system, since apparently we don't build them here in America? You got to be able to build a TV. If you can build a TV, you can build a VRF. But apparently if you're not smart enough to build, and I'm not smart enough to build a TV, but anyway, you know, sick buildings. So engineers start doing like other professionals, defensive engineering, trying to cover the butt, and things get more complicated, and then y'all got to, quote, make it work. And that's kind of tough. EERs. These EERs get pushed higher and higher and higher, so manufacturers start playing games. One of the games is to kill the latent capacity. And we were in a job in New Jersey. We were in New Jersey the other day, and the unnamed big HVAC manufacturer had changed out some units. The best we can tell, they went from 3 rows to 2 rows on a little piece of DX equipment. You probably can't even get a 3-row coil anymore, and it probably killed the latent capacity. So anytime you have so there's a lot of things going on there. So I would just say if you ever get a chance to influence the engineers, tell them to put in a DOAS, a dedicated outside air system. Strip all the moisture out before you pump it in the building, and then live happily ever after. But they're expensive, so that's not going to happen all the time. Sequences of controls may even be contradictory sometimes. And you know, worst of all, you guys have no real direct authority over the mechanical contractor or the control company. It's hard to get them on site sometimes, right? Now, you know what all those guys say to me about y'all. I mean, I'm just quoting, I'm not cursing, but they go, I can't get the damn tab guy on the site, you know, much less the commissioner or whatever. I think the commissioner runs the county government or something. But anyway, they all complain with each other. I would say, you know, the engineer has some control over the purse strings, and then the general contractor generally has control over all of y'all's purse strings a lot of times. And so, you know, get to be buddies with the engineers. We're going to talk about that in a minute. And get to be friends with the general contractors. I'm not saying you got to go drink beer with them on Friday night, but, you know, they're controlling the flow of money, and they might could help you get the HVAC guy. Now, that's a fine line, you all. You want to go, man, you go whining, you know, all the time. But, you know, people tend not to screw their friends. and the people they admire. So, find a way to make your voice heard. All right, so we do a lot of federal work, or at least a few of us in our office are focused on that, but we really do probably more. Our company does more K-12 than any other market sector. But the federal government's embraced commissioning pretty much at all levels. And the state, has anybody ever worked for this, done a project for this prestigious institution here, GSFSC? A piece of cake, right? Everything was easy. We're with the government. We're here to help. Anyway, they generally will do a lot of commissioning, require commissioning on there. But then other clients don't do it. What percent? I'm gonna do it this way: 25%, 50%, 75%. What percent of your jobs have a commissioning spec? 0 to 25, raise your hand. Okay, 25 to 50. Okay, 50 to 75. 75 to 100. Wow. How are all of yours requiring, or most of them requiring commissioning? I mean, what kind of client is it? University clients, okay. So a lot of university clients have figured out, it's well worth it. And at least it gives the tab guy somebody else to try to help pull things together at the end. So I think commissioning is a good thing. My father served on the St. Paul in the Korean War, and before it went to war, it was commissioned. It was the first time I ever heard of commissioning, so it's probably a good thing. Now, the stakes are a little higher on a heavy cruiser, fighting in the Korean War and the World War II and Vietnam, but commissioning a building is not an unreasonable thing. So like I said, we hide it in the tab section sometimes. Is that a bad idea or a good idea? Bad idea? Bad idea, yeah. You got stuck with a bunch of commissioning, right? You're like, he's not going to make us do that. I'm kidding. And then process commissioning. I put a little picture right here, technical versus process commissioning. If you know what those two terms are, who loves process commissioning? You're going to raise your hand, and then we're going to do who loves technical commissioning. Which of those two? Let's reword it. What is most important, process commissioning or technical commissioning? All right, if you like process commissioning, raise your hand. All right, if you like technical commissioning, raise your hand. Now, I don't mean to offend any process commissioners, because I guess there are not any here, but that's just paper. Paper's good. I used to make my living at paper. Now we sell electrons. We don't have scribes and ink and vellum and rapidograph pens, and everything now is just ones and zeros in the end. But, you can only do so much with paper. You got to get out there in the real world and make it work. So I think process commission is kind of BS. And the guys who just think they got to generate the paper, I don't think they really get the big picture, and they don't get out there and try to do a functional performance test, which is to see if the widget's really doing what it's supposed to do. Here's a few of, don't go straight to the green slide. That's some guy on the second row over here. I stole that from him. But, I know everybody gets all fired up about global warming, but I thought you'd like that bottom slide. These are panties from 1712 to 2006. And if that doesn't prove global warming's real, then I don't know what does. I think they went away. We could just, man, Mark, I was trying to stay out of trouble, and now you go say that. But anyway, I don't have a red laser, but in the upper corner, you got there first, but then the sprinkler guy came in and put his crap in front of the access door. Or we got traps here. Traps are great, and it's great to vent the trap. But if it's a draw-through coil, then it's negative pressure in there, so the water's trying to come out. And I don't know if you can see there's some holes drilled in the top of those caps, and the air's trying to come in, so the two fight each other, and it's not a good thing. So, you don't want to vent the, if it's a positive pressure, then all you get to do is you got a little air conditioning system there. You stand in front of those little 3 holes, so hot on the roof. But anyway, there's just some crazy stuff that happens. This is temperature and amps. I know it's hard to see, but you know, it's 90 degrees outside and the heat tape's still doing its thing. It's self-regulating, but not very well. It's too hot for the heat tape to be running. This is primarily for those of you that commission, but probably the weirdest job we ever commissioned was that borehole thermal energy storage system that I had in the beginning on the upper side. We do some weird stuff, and this is geothermal heat pumps, and we got bores going down in the hole, but they're arranged in concentric circles. And I'm sorry, it's kind of washed out up there, but that thing in the upper right corner, the black picture up there, that's not really a person with blue eyes that's been drinking a lot, and it got red around the middle. That's a beta. So you send the cold water in the wintertime to the middle. You try to store some cold. And then we actually have reversing valves, which you would think of normally on a refrigerant side. These are the reversing valves. I think what were they, 6 inch, 8 inch? How big were they? 8 inch? 8-inch valves there, so we can flip the flow around to go to the middle or outside. And you know, people looked at these drawings. This is about a $5 million mechanical job. And they're like, what the hell is that? You know, and what was this guy drinking when he came up with it? So we knew it was going to be a little bit tricky, but we got lucky. We got a good mechanical contractor. We got a good driller. But we had to dream up some stuff. So this kind of project here, it's a little hard to see, but we excavated what would be a pond in South Georgia normally, took about 4 feet of dirt out, piled it up in the corner, put all this crazy pipe in there, and then had to come back and start filling in the dirt. And we knew they were going to snag the bulldozer on it or break some of those lines, so we put pressure transducers on there, and we put a makeup water line on there, and we hooked it to our iPhones. And then whenever the guy snagged the pipe, which was only about 3 times, the phone went off. You call the superintendent, you go, stop, go out there in the clay and find a wet spot. You just cut the pipe in half, you know. And so they did, and we lived happily ever after. Out of 306 boreholes, we ended up with one that leaked, like, I don't know, several months after startup. But we found it and fixed it, valved it off. And so we had to do some weird stuff. We had some big pipe. You know, not a lot of mechanical contractors used to weld in HDPE. Although I do think you're going to see, you know, in the next 20 years, all the pipe inside is going to go to plastic. Now, I may be wrong, but I've got a lot of copper and steel, and prices are high, and it's harder to weld steel than it is plastic, and plastic never corrodes. So I think we're going to see more plastic pipe. Has anybody run into a job where they see PPT or PPRT, polypropylene pipe? You ever seen that? Aquatherm and different things. And sure. I gotta check the clock here because I don't want to lose my $100. I'm glad you asked. I got 3 or 4 minutes. Kiss my butt. 3:49. All right. When do I got to be done here? When do I got to be done? Anybody know? Where's my? Oh, wait a minute. I'm stuck in my back pocket. 4:30. 4 o'clock. Y'all are lying. I'm full of shit. When am I supposed to be done? 4:30. All right. We're good. Thermal conductivity at that site was something on the magnitude. Do you remember, Brandon? 1.6 or something. So the thermal conductivity we've encountered in our geo work, the best has been maybe 2 in granite. Worst has been dry sand in Nevada and Las Vegas at 0.9 or something. The weird thing about the Earth is geology in general, it's not really a conductor and it's not really an insulator. So in English units, which is the only thing I know because I'm old, and we're still using English units, right? I mean, how many meters is it to the ceiling? I don't know, 3 feet-ish, football field, 10 yards, 9 meters. The weird thing is copper has a thermal conductivity of 200. So an engineer would say, well, that's a conductor. And then aluminum's a little bit under that, you know. And then insulation might have a K value, kind of like a U value, but a K value of 0.05 or something. So that's an insulator. So what the heck is 2? You know, it ain't really a conductor, but it isn't really an insulator. It's kind of in between. So it's mostly just thermal mass, and heat flows slowly. And that's how things get screwed up. Is no mechanical engineer ever got any geological training. So he didn't, dirt, rocks. If I was going to do that, I'd been a civil engineer. Because, you know, they do dirt and dookie. That's really all they do is dirt and dookie. At least at Auburn before, like my son's just got his degree in computer engineering because he didn't want to work for a living like I had to. And then he's working on his master's in software engineering. So he'll probably go to California and get screwed up and I'll never see him again. But you know, back in the day, the smartest guys were the chemical engineers, you know. And if you flunked out of that, you'd do electrical or mechanical, you know. And if you flunked out of that, then you'd do civil. If I got any civil or industrial engineers, I'm fixing to piss you off, sorry. But anyway, when you flunked out of that, then you do, no, not structure. No, CM, but you do imaginary engineering. Does anybody know what that is? I'm kidding, industrial engineering. We had an engineer in our office who was an industrial engineer, smart as a whip, and passed his mechanical PE. And he was a GOTech boy, so he was smart. But, you know, civil engineering, we used to like to make fun of them. But anyway, and then after that, I don't know. I'll make everybody mad, you know, go into business or something. I don't know, I'm kidding. But the ground is closer to an insulator than a conductor. So when you're trying to store coal like we were there, really great conductivity is not great because we lose the cold we built up. And then poor conductivity is not good either because you got to stick a lot of pipe into the ground. So the work we're doing at Fort Benning right now, we actually just pull liquid water out of the ground, like a well, and then you heat the building with it, and then the building makes waste coal. And we don't have much of a winter here, so we got to cool it down a little bit more with a dry cooler. And then we put that down in the ground. And then when the economizers won't work anymore, where's the other guy that talked earlier? Had some work at Fort Benning. Is he gone? Anyway, the Fort Benning, he said the hospital there, and I think he said it had no economizers. But once the economizers don't work, then you pull that waste coal out of the ground. You cool the building with its own waste coal, and you dump its waste heat into there, and then put that down in the ground. But Georgia is the hardest place in the universe to get permitted for that. Florida's easy. 2-page permit, $50. Georgia, it took us 2 years to get permitted. In Virginia, where the EPA themselves still regulates, hasn't designated to the site, you just call up the EPA injection control coordinator and send him a 1-page thing of, hey, we're just sucking the water out and putting it back down. We're not putting anything in it. And he says, okay, you're done. So, you know, I'm a Southern boy, so I believe in states' rights, but it's a pain in the butt when each state is different. And professional engineering, you got to get registered in each state. You guys are the luckiest people on the earth, you know, because you're not really regulated as a contractor or a construction guy. You don't have to have a plumbing license, like Brandon Caves, who's licensed in plumbing, Mark Andrews. And you ain't got to have an engineering license. So, you know, it's kind of, I'm happy for you, you know. The government's not there in your face. But, you know, one day it might benefit to get regulated. It might weed out some of the competition. But, you know, whoever said they wanted to be regulated, you know, I don't really mean that. So anyway, my only point in any of that stuff was we had to invent ways to commission this stuff. We were involved with the commissioning, and the contractor had a commissioning. But when you're doing commissioning, sometimes you got to get creative to try to figure out how to see if the system's really going to work. And certainly data loggers that were mentioned earlier are very helpful to try to make sure you know what's going on. My last project I'm planning to do, I'm 59, and we got shortlisted on a NASA project where we're going to put some heat down in the ground. And we didn't get selected. They said, well, that's some bitch, he doesn't know anything about the moon, you know. But I was like, heat transfer is heat transfer. It doesn't matter. So on the moon, the sun goes down for about 2 weeks at a time at the equator. Pink Floyd lied, right? He said it was the dark side of the moon. Y'all remember that? There is no dark side of the moon. It's just tidally locked. So you see a little sliver, and then you see a full moon. Here's the sun over here. And then you see a half a moon, and that little orbit takes 2 weeks. I mean, a month, right? It takes a month. That's the cycle for the moon. So anyway, we want to stick some heat down in the ground and keep the electricity going. Only other choice is nuclear fission. which I don't think Mickey Mouse is going to let them launch that from Cape Kennedy. But they might. NASA's hard at work at it. And solar. But when the sun goes down, solar doesn't work worth crap, right? In fact, we really want to store heat at high temp on the Earth because all this windmills and it's really wind turbines. All that and all the PV in the world has not taken 1 kW of coal and hydro, and of course there'll never be any more hydro, natural gas, because, you know, when the guy calls up, they call it dispatchable. He goes, hey, I'm going to need 73 gigawatt hours tonight. And the solar guy says, sorry, you know, it's going to be cloudy for the next week. I got nothing for you. The wind's blown. So until green energy is dispatchable, until it's available 24/7. Because how many of you would like the electricity in your house to be there 24/7? So just saying, that would be a good thing if it's available 24/7. All right, why did I put the Waffle House in the upper right corner? We affectionately refer to that as a Waffle House tab report. So you leave the main office, you just find a Waffle House that's close, you write up the report, you eat, you go home. That's a Waffle House tab report. So anyway, I'm not trying to suggest you do that as a member of MEBB, but sometimes that's what happens. And that's why that picture's up there. And sadly, tab doesn't happen till the end, and the kids are coming to school, and you know we're going to open school one way or the other. Get your stuff done. Get out of here. You know, you got trades crawling all over each other. You go to the job site. The equipment's not powered. You know, they told you it was powered because they lied because they wanted to get you on the job site because you promised them you'd be there 3 weeks ago. You know, there's all kind of stuff that makes it tough to do tab. You ever got there and the engineer didn't put Pete's plugs in or dampers or anybody? Access panels, you know, that makes it a little hard to tab. So we're guilty of that. If you just, whatever engineers are driving you nuts, say, hey, just come hang out with me on a job, just for a couple of days, see what you think. And maybe they'd take you. And then I've talked about this already, the independent thing. It's great that you guys are pretty much independent of everybody else on the team, because then you can say, well, the engineer's lying. He didn't know what he was doing. Now, you don't want to do that too much because you may win the battle and lose the war, but, you know, it's good that the fox isn't watching the hen house and that y'all are generally independent. But it's also tough to motivate all these other players to do what they should do when you don't have direct control over them. And as I mentioned earlier, a tight relationship with the GC and maybe even the engineer, which I'm going to suggest in a slide in just a second, is important. So low bid, you ever gotten underbid? Anybody ever gotten underbid? Did you use profanity after you got underbid? Like, how the heck did that darn guy put that price out there, and how's he going to get it done for all that? Yeah, so you know, that's tough when you get underbid, and you know what's going to happen. He's figuring he ain't got to do the whole scope because engineers wear beanie caps and sit in the office and don't want to sweat, and maybe they're not going to come out there. So, you know, engineers oftentimes don't have the field experience to put the stuff in there you need to do the job. And then a lot of times, and I'm not defending my industry, but architects, we got any architects in the room? Thank God. All right, so, you know, a GC might mark you up, what, 10%? 15, if things are really great, 20? In general, on a lot of jobs, especially institutional work, they have declared that the fee structure is 6%, like your real estate commission. So the architect gets 6%. You know what he wants to pay the engineer? 3 to 3.5, maybe 4. So he's putting somewhere between 50% and 100% markup on the engineer. Well, he should put some markup. He got the work. You know, so I'm not saying he's not entitled to markup, but when you cut the design fee, the professional fees in half, you spend all your money getting the job out the door. So I don't think this inherently the engineers are bad people and they don't give a crap, but they spent all the money by the time they got the design done, and so they don't end up doing a good job on submittals and tab. And we're weird because we got tab in-house like a few of y'all's firms. And yeah. So, the bottom line is that if you really want to raise the industry a little bit, we need to interconnect the TAB and the commissioning folks with the engineers and try to develop a system that's better than what we often have now. I got a couple other things on here. Factory startup. Has anybody ever really seen a crappy factory startup? Have you ever seen the factory guy? You know, that's another problem. And I got a list of questions we're going to throw up in a minute during the discussion time. We'll talk about anything you want to. But here's what I'm going to suggest. I'm going to throw out some ideas, and you can throw them in the trash can. I hate to tell you this, but you know where that little black little box in the upper right-hand corner came from? The evil AABC site. You know, I'd love to see that on the NEBB site. I mean, Andrews Hammock Powell is an NEBB member, and we got NEBB supervisor, a couple of them, and I like NEBB, you know, but y'all think about that. Think about doing a lunch and learn between your firm and the engineering firms that you work with, you know. Make it a 1 hour thing, and I'll talk about that in a minute, and we'll do it at lunch. Another thing is maybe go to an ASHRAE meeting. Not that they're perfect, but, you know, if you show up, the engineer may go, hey, maybe this guy gives a crap, you know? Anybody ever been to an ASHRAE meeting? All right, I'm not saying go to the national meeting that's every year, because there are some great seminars up there, but ASHRAE tends to get a little academic, you know. I keep all my old ASHRAE books because they got the most information in them. I don't know if it's the lawyers or what, but, you know, like you want to get equivalent full load hours now because you got to crank out some energy thing right quick. You got to go back to, I don't know, 1983 or something. So ASHRAE's a good place to meet some nerd engineers. And I'm going to throw out the idea of some guide specs for TAB and BCS. You shorten the specs. They're not so complicated. They're achievable in the field. You preserve what's important, and you strip out what isn't important. I just think that's another idea. Now, a lot of times engineers have no choice. We're working for the federal government. They know everything in the universe. So we have to go to a website and download NAVFAC Southeast spec or Army spec or whatever, or GSFIC, whatever. So a lot of times our hands are tied, but we're usually still allowed to edit it, you know. And then a lot of times on our private work, we've developed specs over the years, and we're amenable. Brandon Caves streamlined our TAB specs quite a bit, looking from his experience as a TAB guy. So I'm just throwing out, y'all might want to quit. Now, maybe that's too big a thing to bite off for MEBB. Maybe it's done at NEBB level, but I think that would be helpful. I think most engineers would welcome that. And project protocols is a little bit more obscure, but I'm going to talk about that briefly. So, you know, why would you want to do this, lunch and learn, and then why would the engineer want to do it? Well, for one thing, they need PDHs, just like y'all do, right? You got to be here, you got to get your hours in. And the good news is, like, unlike the American Institute of Architects, which makes it hard for it to be AIA certified, or the green thing, USGBC certified, most of the PE boards, Florida's a little bit different, but most of the PE boards are pretty easy about what the PDH is. You know, if the topic's good, we have a generic certificate you're welcome to, and you can have it and you can put your name on it. And, you know, I mean, you get them off the internet. Yeah, no, you can't do that. You could get charged with fraud if you give the engineer credit for his whole 15 hours of PDH he had to have, and it was a 30-minute drinking session at a bar. But you know, engineers need those PDHs. And it's fairly easy to do it. A good friend of Mark's told me, he said, why do y'all want to do that green stuff, man? It's just a bunch of liberals. And I was like, he said, those people got more money than sense. I was like, well, you know, most of these school boards we work for in South Georgia, they got a whole lot more sense than money. And they squeeze it out of us. They know how to get the fees down. I said, it's much easier to work for people that have more money than sense. One day I'll tell you all about our project we did at Al Gore's house after he screwed up, but that's for another day because I'll run out of time. And then what I was alluding to briefly earlier, seminars brewing. I thought that up myself after the thing I was talking about. But, you know, instead of having lunch and learn, you can do that sometimes, and have a seminar. But we're brewing a seminar at 5 o'clock. Why don't you come? Most craft beer is exploding. After Prohibition, you got down to the big 3 or 4, who are all now foreign companies. Budweiser, Miller, Coors, whatever. Those are all foreign companies. But there's a lot of craft brewers almost everywhere. So have a seminar brewing at 5 o'clock. I'm not saying get the engineers drunk, but you might. But it's a good relaxed atmosphere instead of a meeting with the GC and GSFIC and general contractor and everybody all standing around screaming at each other. You don't get anything done. So I just want to throw out that. I'm not advocating you drink alcohol, but I have for quite a while because it was 18 when I started. So lunch and learns are relaxed, like I said. Now, do remember this, though. Engineers' egos are fragile, right? They're supposed to be at the top of the pyramid. They're supposed to know everything, You start talking about stuff they don't know. So don't beat them in the head, but just, hey, you might consider, you might think about it. Be a little soft with them, because be what the Bible calls winsome, It's like I go to a thing in Atlanta every Labor Day weekend, and there's some guys out there beating on the Bible and whatever they got on their sign, pick it. Gays are going to hell or whatever it is, I'm like, I walk over there, I was like, you really think you're going to attract some of these people to Christianity like that, And then there's others out there just handing out water with a Bible verse, So I think you can usually get more with sugar than vinegar, So be winsome. ASHRAE meetings already talked about. Guide specs we've already talked about. Don't write them up like the reps do. We get guide specs all the time, full of proprietary crap that we don't really need, but it locks the other guy out, It doesn't matter whatever it is, Train, Carrier, LG, Mitsubishi, whatever. Everybody's going to put their proprietary stuff in there. If you do it, at least put it in red. Say, well, this means only MEBB can do this job, or, the headquarters of the organization that certified you must be located in whatever. That doesn't make any sense. Now, I'm not saying you don't want to block out CBS and NBC and ABC, but anyway, I just think that you should put out a balanced spec that would be better for y'all and be better for the engineers. Help us out. Protocol documents is really, it's a little more risky, but it's kind of under the heading, say what you mean and mean what you say. Mr. Engineer, if you're going to put this in there, it's going to triple my price, So I'll try to get a performance test on these 17 VRF systems that's 17 condensing units that have 10 cassettes tied to each one, so that's 170 systems, But it's going to triple the price, and if you're not going to make the tab guy do it, like you didn't on the last 3 jobs, then my competitor is just going to, in essence, be hanging you a bird and only do about 20% of what you want. So say what you mean and mean what you say. And communication, obviously your client is often the GC or my client's the architect, and you need to connect them in the loop. But, what if, heaven forbid, you looked at the engineering firm and you said, okay, I need to talk to this person about that and this about that and this about that. It would make things go smoother, I think. And I think that's good. Response times, what do you expect of the engineer and what does he expect of you? What's a reasonable response time if you want to try to work on things together? And what's a priority for the guy, Some people will die on some cross that doesn't matter, and then the one that mattered, they're not going to die on that. So everybody's got different priorities for different reasons, but, do the important stuff first. All right, so we're going to open it up for Q&A now, and this is where I'm probably going to get in trouble, because I'm going to give you some sample topics. We don't have to talk about any of them, but I'm going to throw some topics out that struck my fancy. Engineer spec tab, and then 2 seasonal balancing things may or may not happen. Is that needed, not needed? This is one that blows me away. We now have the 9th edition. I'm sure all of you own it and have read it cover to cover, right? Yeah? Somebody have? All right. Nobody lie. How many of you have downloaded it and read it cover to cover? All right. Well, you got to pay for it, but right? But anyway, I was astonished. Brandon told me this, and I was like, that's bull. There's no temperatures in there. You don't have to have temperatures. I'm like, are you freaking kidding me? We're in EBB. I think it's the best, I don't know. Some people argue A, B, C, whatever, but I'm like, no temperatures? Now, usually there's a spec and an engineer out there, but I'm like, what the hell is going on here? I mean, flow without temperature is generally meaningless unless you're snatching farts, which would, be like sitting over the toilet and the exhaust fan. CFM would be good there. Who wants the entering and leaving wet bulb of the air going in the bathroom and going out or whatever? But and I'm not saying there's not unnecessary stuff, and that you should do enthalpy calculations on everything in the universe. But I just think temperatures might be a good thing. Just saying. How do you influence engineers to say what they mean and mean what they say? Enforce these provisions or don't put them in so everybody bids at apples to apples. Now I know this is going to sound counterintuitive. What if you say to them, hey, why don't you go buy a flow hood or I'll loan you my other one and maybe a couple of hydrometers and just go spot check a couple of things. See if these guys even came on the job site. If they even bothered to take a magic marker and pretend that damper had some meaning to it. I just, if you want to do good work, do good work. If you don't do good work, go do something else, Just a thought. The specs, getting those better. Don't get into some specs get into the means and methods. Y'all need to be left alone on that. You need to deliver the information at the end. It's not that critical. And buildings aren't flow labs. That was alluded to in one of the other talk. These curves, yeah, kind of, sort of. I mean, they're good in the lab. They're off a little bit in the field. I know I've screwed up your world by telling you things don't always go as a square in a cube, but it's close enough most of the time. It's really close to the cube, and it's close to the square. So don't think that's no good anymore. But buildings aren't labs, and some engineers think that, this is a lab experiment. And they demand too much. And that's probably ashrays. I mean, y'all aren't going to be able to fix everything, but I'm just throwing out you might fix some things. All right, we can talk about the topics I've presented today, but, I don't know that that's worth talking about or not, but that's a possibility. Are there substandard firms in MEBB or NEBB or AABC? What do we do? How do we raise the bar? How do we make NEBB the premier tab commissioning organization where just the fact that the engineer's got a MEBB guy on the job site, he ain't got to worry? I mean, I don't want to be rude at all because I was invited here. But, just because it's an NEBB guy, it don't necessarily tell, because we don't do a lot of tab in terms of competing for tab work. We just do tab because y'all don't want to go in a chicken plant and get blood spread all over you, or we're doing underground geothermal or something. We don't chase tab every day of our lives by any stretch. But, it should be that, hey, NEBB is NEBB guy. Get the submittal. And I'm like, hey, we're good, And so y'all got some protocols in place about that. If the guy screws up or whatever, they can call NEBB and y'all pay your dues into that. I don't know how often that happens. How often do you police your own ranks? Our police are the government, and they have laws and jail and fines, and if you get your PE license, it kind of becomes a critical thing to your livelihood, and they can take it away, and so, I've managed somehow to not have a felony yet, but if I got a felony, I can't be a PE anymore, so, factory startups, how do we get those done at all, or maybe done right, How's the NEBB QAP program? Is this conformance certificate? Off of the website, I got the page, and then there's a form you send out. I couldn't find the actual certificate, but, should y'all push that? Most people aren't even aware it exists, That would be a nice thing to differentiate you if it's there, But, I mean, like, oh, man, I don't want, they got that, and then I screw up, and then they're going to call MEBB, and then MEBB's going to call NEBB, so, but y'all have got it in there, Y'all own the organization. Take it out if you're not going to do it, or push it, advertise it. That seems like dealing with control companies, ain't no good answer to that. So I got to end at 4:30. We got about 15 minutes. Does anybody have a question? Yes, sir. All right, who thinks that a test and balance agent might, I'm loading the question, sorry, might ought to measure some temperatures somewhere, somehow in a building? All right, so y'all go get that fixed. I don't know. Go fix it. 10th edition or 9th edition addendum. When Clint and I don't finish designing the job, we get it out on the street because we're getting yelled at, and we just put it all in the addendum, right? You know, and it's tough in the addendum because you need the specs to hold the plans down, but you don't need the addendums for anything. They're just little sheets of paper. Although we did work for an engineer one time. It was industrial stuff, so it wasn't really an architect, so that was good. But you know, he designed by addendum. The addendums were thicker than there, but you know, maybe get an addendum. I think temperatures would be a good thing. Next question. Yes, sir. What do you think? All right, so you know, I think the theory behind the seasonal testing. Hey, all right, let's do hands then. All right, who thinks that specifying tab, just testing, adjusting, and balancing on a building is a good thing? All right, who thinks it's a bad thing? All right, who thinks that the system ought to work in the summer and the winter? All right. So those are probably some of the motivations that led to that. It's just maybe the execution that's screwed up. So, you know, if you're there tabbing in the summer, maybe you could do that seasonal balancing right then. You know, fall and the spring, who knows? Someday it's winter, someday it's summer. Wintertime, you know, who gives a crap? It's hot down here. I'm kidding. But, you know, you're going to get people that complain when it's chilly and cold. So, you know, if it's a heat pump, you know, how do we know that it's going to go into the heating mode? You know, if Carrier says, don't run this sucker in the heating mode when it's above 75 degrees, or let's say 90 degrees. Don't put this thing into the heat mode when it's 90 degrees outside because you're going to be buying the compressor. Because when you turn the evaporator coil into that outdoor thing that's sitting out there, and the entering air is continuously 103 degrees, that magic Carnot engine widget is going to try to move, you say it's a 3-ton system, it's going to try to move 3 tons, you know, into the building, and it's really going to end up moving 5, or trying to, and then the refrigerant pressure gauge is going to go to crap, you know, and so so I think something needs to be done, but I don't think engineers need to spec it. I think one of the other I told you 2 reasons I think that happened. The third reason is, you know, we just kind of pull some stuff out of our butt of how many people are going to be in this room, you know, the architect and the lights and on. And so, you know, then you have this magical thing sometimes, oh, wait, go back and rebalance the whole thing for temperature. I mean, what does that mean? You know, I mean, is the sun coming through the windows or not coming through the windows? So I think part of it was trying to mediate this academic thing, because in reality, you can only design for 1 hour. That drawing is a snapshot in the South of what was allegedly happening on August 18th, you know, east-facing glass at 9 a.m. and maybe 3, 4, or 5 for south-facing and west-facing and north-facing, you know, and it could be BS. You know, before the job even gets built, this could get turned into 6 classrooms or something. So I think the motives to do it were good, but I think it adds a lot of money, and people are like, I really got to do this, and is this engineer going to make me do it or not? You know, that's why you go lunch and learn, or go buy him some beer and go, look, take this crap out. You don't ever get it. You don't ask for it, or make it happen. You know, make the guys that are bidding it do it. After they get burned 2 or 3 times on a seasonal balance because they didn't get their money, they may start doing it. But I don't personally, I don't think you need a summer seasonal balancing if you're there in the heat doing the tab. You know, if you're there in the winter, yeah, I think you could do that as your seasonal winter, but I do think you have to visit the job site again. But you're probably like the engineers, all the money's gone, and you got 10 other jobs biting you in the butt. So what do you? Anybody else got another thought? Oh yeah, you guys got talking to Mike, so this is being taped.
All 15 air handlers had plugged up filters. Mm-hmm. and half of them, the chill water valves will not open, the controls will not call for it.
But that's your fault, right?
Oh, exactly. So, I mean, this is the report I'm sending in.
Yeah. You got to bite the hand that feeds you, right? I mean, so let me ask, I should have had this question up there. What do you think if you work for somebody else other than the mechanical contractor whose hand you have to keep biting because he screwed up? Would y'all like your tab section to be required for you to work general? This is a yes or no question. I would prefer if the specs require me to work for the general contractor. Who would like that? Who would like that? Okay. Who wouldn't like that? Okay. All right. What if the spec said, it's not even in the construction contract, thou shalt work directly for the owner, like the architect does. How about that? All right. Who gets jobs that have that in it? Yeah, so you got a few smart owners. But the bulk of you don't get that situation. Now, we do a lot of DOD work, and the federal government contracting officers, God, this is being taped, right? Anyway, let's just say this right. So some of the contracting officers would prefer not to issue two contracts, one to the design team and one to the construction team. And sometimes those two people fight, and that's not any fun either. So the federal government has switched to a lot of design build. The design build can work great. If you're building the bridge over here, maybe that could be design build. If you're building a submarine, maybe that's a good thing. But design build often puts the engineers in the same conflict that y'all have with the mechanical contractor, which is you have to bite the hand that feeds you. So we've not had a whole lot of luck convincing owners that you need to issue they don't even want to issue a contract to the architect, the God of the universe, that puts all the engineers under him. And they used to be the God of the universe when they were building pyramids. But now they subcontract it all out, right? Mechanical, civil, electrical, communication, surveying, ad nauseum. So I'm prejudiced. But I wish there was a good answer, and I wish there was a way to get owners to be willing to hire y'all straight up, because that would be best for everybody.